right, hi everybody. My name is Drew, and I'm going to be talking a little bit about how to turn your Emacs into a intelligent and full-featured IDE. I'm going to be using Python as the example, for the purposes of this discussion. My hope, though, is that some of the techniques I'm talking about will hopefully you should find some broader application in other sorts of environments. I'll talk about that a little bit at the end. But anyhow, it's a pretty, we'll have plenty to talk about with Python and some interesting things to show you. And I hope you guys find it useful. Thanks for coming out. So just to give a general sense of what I'm going to talk about, I'm going to start out with a little demo, just kind of showing you more or less what you can hope to have at the end of doing some of the steps I talk about. And then I'm going to basically show you how to use it yourself, how to install the packages I'm talking about, and how to customize it to your preferences. And for those of you who are interested in trying it out yourself without the pain of changing your existing config, I've created a repository on GitHub with a virtual machine, if you guys use Vagrant and VirtualBox at all, that you can use to try out locally yourself. So you can feel free, if you want to brave the Wi-Fi at WeWork, and try it out as we talk. Otherwise, I'm planning on keeping it up, and hopefully it'll be there as a resource for you guys to check out as we, after this talk. So basically, in terms of thinking about what can you create in terms of making Emacs a more of a traditional IDE-like environment, there's a few things that I think we're going to talk through today that should be useful on that score. One of them is being able to find files and switch between projects easily. Another one is going to be navigating through function definitions and variable definitions in a way that's sensitive to context, and also of documenting what you see in real time. If you see a function or if you see a variable, being able to see where it came from and what it means. And then, also when you have complex function calls or other constructs, it's nice to be able to have some help for that sort of thing. I mean, these are features that you expect to come along with IDEs like an Eclipse or an IntelliJ or something like that, or a Visual Studio. And in fact, it's also possible to get them from Emacs. So to start out, I'm just going to do a little demo. And I'm just going to use my own setup. So here I am, just in the scratch buffer. And let's say I want to go to a project. I've taken the liberty of opening some of these files for you, but this is basically how it works. Well, so you can do things like, for example, bring up a list of project names. And this is a package called Projectile that lets you do that. And I'm going to go to a project called vbench. And as you can see, it has the ability to sort of interactively search for it. In fact, it happens to be highlighted, so I'm going to switch to that now. And in terms of what file I want to go to, I want to go to a file called runner.py. So, in fact, typing in a few letters gives me that file, and now here we are. There we go. So I'm in the file, and let's say I want to make a few edits to something. So just for fun, I'm going to define a variable for largely throwaway purposes. We have this thing called a benchmark DB that we've imported here. So let's say I want to create an instance of that. So I do DB equals, I'm just going to type the letter B, and right away you can see I have an autocomplete for this benchmark DB. And I can complete that, and I can ask, what do I need to initialize that? And I can call something up that just tells me I need the path, so I'm going to go ahead and do that. And then just for fun, I'm going to call a method on it. So if I do db.g, what do I see? Well, I see all of the getters defined here. I can choose this getBenchmarks function, and it doesn't take any parameters. So that's something nice that you can set up when you have a little bit of auto-completion intelligence in your Python. Let's do a little more exploring. So I'm going to look at the benchmark runner class, and in particular, I'm going to look at the init method. So I'm going to go look at the init method, and I notice at the end I've got this thing called a bench repo, and it looks pretty complicated. So if I want to learn a little bit about it, so some of the things I can do, I can look at the doc string with just a keystroke here in another buffer, and I'm just going to zoom in a little bit so you can convince yourselves that that is in fact the doc string for it. And I can also navigate to its definition. So in one other keystroke, I can see where I've imported it from, and in another one, I can go to the definition in a different file. So this is a great way to navigate quickly and to do so in a way that respects kind of what you're investigating, if you're looking at a bug or something like that. So looking at the end of this init function here, let's say I want to check out the copy repo command. So it also, this auto-completion feature is also intelligent enough to know what class methods look like. So it jumps to this method that's defined off of self. And let's say I want to look at this this self.prep function and see what's going on there. I can jump as well with a single keystroke. And now if I look at this run command thing, I can do things like get the function signature, go to its definition, which is someplace also completely different. I went the wrong way for that. And this IDE feature also works not just with variables and classes defined in your project, but also standard library things. For example, here's the subprocess module used here, and as you can see, you can bring up a pop-up showing the arguments, or as we saw before, bring up the doc string for it, which, again, it's kind of small, but hopefully you guys can kind of get a sense that that actually is, in fact, what we are looking at. So now we've gone so far afield. How do we get back to started? Well, fortunately, you can actually just retrace the tree and end up right back at the original bench repo definition in a few strokes. So hopefully this has done something to show you some of the nice things about having features like this. You get to, from the comfort of your Emacs environment, not just know what possible completions are and get a sense of documentation, but navigate much more quickly than you'd be able to do without this. So what do you need to make this all happen? So the first part we looked at was an interface, involving auto-completions. Is actually sort of a more general than just Python thing. You need some sort of way of showing that pop-up box and showing alternatives, and that's what autocomplete is. Next, you also need a way of parsing the buffers, and that has to be something that's aware of the language that you're using. In fact, the setup that I'm going to describe to you runs a small server in the background that wraps a library that parses the buffers that you're looking at with some knowledge of how your system is configured and what your project environment is. And where the Emacs Lisp stuff comes in is really the glue code. And these are a couple packages called EPC and jedi.el. Jedi, we'll talk about in a little bit, is really the brains of how this all works. And EPC is a bit of middleware that connects Python land to Emacs land. And so we're just going to, I'm actually not going to have an eLisp review. That's an artifact from an old version of the slide. Hopefully some of you guys have seen it before. If not, the syntax is pretty simple. And in general, most of what I'm going to talk about is stuff that you can just copy and paste into your environment. Where I will go into a little bit of detail is talking about how the init file is set up in the VM. And speaking of the VM, this is sort of something that I've created to help you guys try some of these features out if they're interesting for you in a sandbox environment. So basically, you need to be able to run Vagrant and VirtualBox and then clone the GitHub repo, CD into it, and bring up the virtual machine. And the first time you run Vagrant up, it'll do all the provisioning and install the dependencies. And then you can just SSH in. And the initialization code for the virtual machine Emacs is in a file called Jedi Starter.el in that repository, which is soft linked as the .emacs file from within the virtual machine. That allows you to, for those of you who haven't used Vagrant, one of the nice things about it is it allows you to share a directory between your local box and your virtual machine, so that edits on your local box can be reflected there. And the basic upshot of that is edits to your Jedi Starter.el will be reflected in your environment in your virtual machine. So if you want to do some tweaks or do some experimentation within that, you can do that locally in the environment that you're comfortable with, and then try out the results on the VM. In terms of how this Emacs, and so basically much of the rest of our talk is going to be talking about how this file is set up, and by extension, how you can set up your own environment to use some of these features. So basically, the first couple lines in the Jedi Starter.el incantation involve including the package function of Emacs, which I'm going to talk about a little more in a second. Next, there's some specific code for the package setup that has to be done to ensure that all of the dependencies are installed. After that, there's some global config variables and helper functions that I've defined for reasons that'll become clear during the presentation. And once that's done, there's some mode-specific and package-specific initialization that I've decided to put in this thing called the after init hook. I think there's varying schools of thought as to what the best time is to initialize packages. Your mileage may vary. You might have a different setup. I've found that this works pretty well for my purposes. And the idea being the package setup code ensures that everything is installed at the time that Emacs is started, and waiting until that's completed allows you to ensure that you're performing initialization on packages that are in fact installed. So basically, much of this presentation is going to be filling in those commented lines with actual eLisp code that does what you would expect. So in terms of the particular dependencies we're going to use, there's four that I have in the VM. The first is this thing called Projectile. It's quite simple, but I think it's useful and consistent with the idea of sort of turning Emacs into more of an IDE. It basically provides a way of navigating quickly to your different projects, assuming that you use source control, and navigating quickly within those projects. Then there's the autocomplete, which I discussed briefly before, which provides essentially the interface elements that show completions and inline documentation. And then EPC and Jedi, which are really what makes everything tick. They're the parts that are aware of Python and manage the communications between Emacs and the process that's parsing the buffers. So for those of you who've worked with packages before and maybe installed some custom eLisp code, it is possible to just do this very basically, which is to clone these respective repositories and their dependencies and unzip the tarballs and add those directories to your load path and then manually require everything in your .emacs file. That's possible. We're not going to talk about how to do that today because it's annoying and hard to reproduce. The strategy, I'll say instead, it involves package.el. Just to let you know, it is still possible, though, to install these things manually. There's a few other involved steps. If any of you guys are really curious, I have installed them manually before I saw the light and started using a package manager. And you guys can ask me about that later if you're curious. So package management comes in standard for Emacs 24. And you have to do a little bit of work to make it available for Emacs 23, if any of you guys are using that. The GitHub repo, as sort of a teaching tool, uses Emacs 23, and you can look at the setup code, particularly there's basically an eLisp file you have to download and place in the load path, and then everything else after that's been loaded is essentially identical between the versions. And so the incantation to get going with the package manager is pretty simple. You have to require the package and initialize it, and then add at least one repository source to it. And the one that I've chosen here is Melpa, which is one of several options. There's Marmalade, and then the GNU project has one. Melpa, I find, is up to date with all of these packages, and various anonymous sources on the internet seem to suggest that it's pretty well maintained. So why mess with a good thing? I just stick with that. And one annoying thing is you do need to remember the trailing slash on the URL. I actually spent some time banging my head against the wall, failing to include that. And after you've installed, the packages are stored locally, and you can check them out in your .emacs.d/elpa file if you're so curious as to figure out what's actually been installed. And so there's two ways to actually get the packages. The one way, which is not as good, is to use metax list packages, which I'll show you right now. So if I do that, I get in touch with, here we go, and we get a bunch of, we get a buffer that has a bunch of packages in it. So let's say I navigate and put point over one of these things. I can press the question mark key and see some documentation for a particular package. And then there's, I think you press return, or maybe you mark it or something like that, and it gets installed. You can look at the mode-specific help with Control-HM for more details on that. I'm not going to spend too much time on it. I'll say one useful thing about doing list packages is it actually shows you what's built in and installed already. Let me go here. Yeah, here's the installed stuff. And that can be handy just to get a sense of what you already have in case you're curious. So that's the one strategy if you want to manually handle these package installations. The other one is to use the package.el API, which lets you put code in your .emacs file and more easily reproduce your package installs across environments just by using the same .emacs. So what do you need to do that? Well, I've defined a variable that I've called local packages, which just has the names of the packages. If you're curious as to the exact name, you can always go to metax list packages to learn that, or I know at least Melpa has a website that's searchable, and Google and all that stuff also works. Then I have a little function here that I've just kind of hackily put together that, given a list of packages, tells you what's uninstalled. And I've adapted a little technique that if you Google elisp filter stack overflow will look familiar, because Emacs built-in doesn't have a filtering function. But what this does basically is it allows you to, using the package installed p command, which basically tells you whether a package is installed, just returns a list of only the uninstalled packages. And then, given that list, I have some code that binds it to a temporary variable that I've called need to install. And when that variable is non-nil, I refresh the contents of the local package manager, and then for each uninstalled package, I call the function package install p, where that's the name. And so that's the command that does the magic, package install. So then now you have your package installed, and what remains is just to enable them. So I'm going to take the easy ones first. The first one is Projectile, which is the package that allows you to navigate between projects. So what it does, and the three commands I have up there are about 99% of what I use with it. There's other stuff online that the more sophisticated types among you might find interesting, but I find that this is more than adequate for my purposes. What it does is it remembers different projects that you navigate to by basically what repository they're in. So if you navigate to a file in a particular Git repository, it'll remember that and make it searchable via the switch to project command, which I showed you earlier. And then you can interactively search within that project for different files. And then when you're all done, kill all buffers with a given project, which is particularly helpful, when you get to a point where you've got 3 different projects open and 20 buffers each. It's kind of nice to have that. And it's a very nice, very easy to use documentation. And you can look online for a very thorough README file. This Batsov gentleman, Boris, is that his first name? I forget. I think he also does Emacs Prelude, if any of you guys are into that. And if any of you guys are Prelude users, I think Projectile comes standard with that. And if you really want to get up and going with it, those are the only 2 commands you actually need to use. I have a couple customizations because I like my results displayed vertically, and those are basically not specific to Projectile. They're specific to something called IDE mode. But in the interest of keeping things simple, that will get you started, and there's a lot of resources online for additional customizations you can do with it. One other note, For some reason, the most recent versions of Projectile have relied on this remote file name inhibit cache, which does not appear to be included in a vanilla Emacs 23 install. At least it wasn't on my VM, which was just an apt-get install Emacs from Ubuntu. So I have this little hack to bind the variable to a safe value, which in this case is true. And for those of you, I forget if we talked about this last month at Emacs, but we use the helpful bound_p function, which given a symbol tells you whether it exists, whether that variable exists. And so when it doesn't, you set it to something safe. So that lets you use it with Emacs 23. Next up is autocomplete. Also pretty easy if you just want to use the default values. That is it. And what does the default configuration get you? It actually does get you something. Oh, one other thing I'll note. The setup that I showed you guys showed the menu essentially right away. If you like that, I sort of like that. There's a vividly named variable that you can set to true, and it does about what it sounds like, which is to show the menu immediately on autocomplete. And what is it, in terms of being active, it'll generally, for most of the common programming modes, C mode and the like, it will be active automatically. But the only completions you have are going to be kind of basic. The dumb and less useful one are the language-specific keywords in case like you really want to have while autocomplete and save those extra 3 keystrokes after the WH. That is an option for you. But the other thing it does is it'll like collect all the words and buffers with the same mode, and it'll automatically make those available to you. The thing is, though, it doesn't know anything about syntax. It can't tell you anything about the appropriateness or the meaning of those completions, which is why the vanilla autocomplete really can be improved upon. The nice thing, though, is that autocomplete does have an interface for third-party packages providing completions to it. And that's what Jedi does, in essence, among other things. So we've talked enough about Jedi, and that's really the centerpiece of this whole operation and the most annoying and difficult thing to configure. This is because there's a few different components to Jedi. First of all, you have the Jedi Python library, which does the actual work of parsing. It provides a nice and pretty well abstracted interface where you can give it a whole blob of text and a position within that file, and it'll tell you things about the context of whatever variable you're looking at or where point is. It's actually not specific to Emacs. It, I believe, was originally developed for the Vim community, but we've still been able to reappropriate it for our own purposes. And you can see more details online if you're really interested in the internals. You don't actually have to know all that much about it to set it up. And then there's this piece of middleware, which is kind of an odd duck, EPC. It's a dependency. It's not used all that much, but it basically works as the glue, and it's worth remembering as something that needs to be installed. It has both a Python package associated with it, as well as a small eLisp package, because it does have to talk between both environments. And then jedi.el is the interface that's the eLisp front end, as well as a very small Python server that talks through EPC to Jedi. This is really what you customize and what you set up, and really provides the interface for working with all this through Emacs. So here's a diagram kind of showing the flow, just because there's a few components that work together. So you'll type stuff in, or tell Jedi you want to do something or go somewhere. Jedi will turn that into a Python function call. That will be, parsed and thought through by the Jedi library, and then the relevant information will be sent back to the Jedi eLisp library and presented appropriately in the form of completions, or like someplace for the, you to jump during navigation. So there's some Python dependencies that are parts of this, and then you have 2 choices, one good and one adequate in terms of how to deal with this. The better option, if it's available to you, is to let Jedi handle it. You need 2 things for this to work. One is pip, which most people, I think if you're working with Python, it's become an increasingly popular tool for managing packages. And it's basically, the simplest way to install a package and its dependencies, analogous to aptitude or yum. The other one is virtual env. For those of you who, it would be roughly analogous to like RVM for those of you from Ruby backgrounds. It lets you manage different Python versions and different sets of packages and switch between them, using some, basic shell commands. And what this allows you to do when you have those things installed is you can just issue a one-time command from Emacs every time you deploy your setup on a new machine, and you'll get all your dependencies in a sandbox environment. The downside is if you use, for example, other package managers, and the one that's from my own experience on my personal box is Conda, which if you use the Continuum IO Anaconda distribution, it doesn't play too well with virtual env. And so if you can't use the virtual env, you're left to do it yourself. Which means that you'll have to do a pip install EPC, pip install Jedi. Globally, you'll have to ensure that when you start Emacs that those modules are in a place where they can be found. And that may involve pointing Jedi during startup to a particular installed Python. I'm going to discuss a quick function for doing that as a sidebar later on, but just FYI, that's why I'm going to mention it. The absolute minimum to hook up Jedi is also pretty simple. You import the library, and then as I was talking about, autocomplete is extensible with different sources, and that's what the add to list AC sources command does. It gives you, Jedi exposes a source called AC source Jedi direct, and you add it. And then the next thing you should do is you should add to the Python mode hook the Jedi setup function. So many of you may already know about hooks. Hooks are basically Emacs's way of letting you add functionality dynamically at certain times in Emacs's life cycle. And the Python mode hook, for example, is called when you're entering Python mode for a given buffer. And by adding a function to that hook, you can ensure that that function is called as an initialization step. The other interesting thing about the add hook function is that it actually adds elements, I believe, to the beginning of the list. And so we actually want to add Jedi setup first to the Python mode hook in our init file. And this actually becomes important because we're going to add some customizations to Jedi variables that are specific to a given buffer that need to be made before Jedi setup is called. So this is done in the virtual machine, but if you're experimenting in your local environment, keep in mind that that has to be called first and therefore added first of the Jedi functions to the Python mode hook. Now, the bare minimum gets you some of the autocomplete function, but it'll only get you the standard library, which is nice. But if you want to, some of the most valuable stuff in Jedi comes from being able to navigate between files in a given project, and you're going to only have a relatively trivial version of that. You'll actually only get files in the same directory in certain cases. And you can improve on that by configuring the Jedi server before it starts up. And this is actually done by setting an Emacs variable that allows you to set the Jedi server args. And the two args that are worth thinking about are the system path, which for those of you who use Python, sys.path is sort of where Python looks for modules. And if you want to specify a virtual environment that is not the currently active virtual environment, you can also do that via the virtual env switch as well. If you're in a given buffer and you want to see what server arguments are active, and this can be useful when you're setting something up and trying to debug it, you can do it by Emacs's describe variable facility, and that can be done by either meta-x describe variable or control H V, and I'll type in Jedi server args, and I'll get a bunch of information in the help buffer. I can see the current value is equal to the project root, and that the global value is nil. More on that in a second. Now that syspath value didn't just set itself. We had to do something for that to be set correctly. And same with the virtual end variable. I've set that to nil. I think most of you will probably also, not need to use that. And basically, to configure both of those, this is kind of the setup that I have in the virtual machine. I have the with virtual end variable either nil or a particular or a string that gives a path to a particular virtual env. But the more complicated stuff is related to defining the VOT project root. So I've defined two variables. Again, lots of different approaches you could use for this. One is a particular sentinel to use in terms of finding a repository. I've just chosen .git here. What do I mean by sentinel? I mean that's a file that you would expect to see in the base directory of a repository. And sure enough, your Git repository will have a .git directory in its root directory, and Emacs has facilities for being able to find that. And then similarly, there's this thing called the Python module sentinel. The simplified example I'll show you here doesn't actually rely on it. The more complicated example in the VM does. For those of you who don't use Python, init.py is a file that has to exist in certain directories for modules to be quote-unquote importable. The location of an init.py file can also be helpful information in terms of understanding what the base directory for a given buffer is. Like where is the base relative to a given project? It's not always the version control root base, and so knowing how to find that init.py file can be a helpful technique, and that's what we do online. So a basic function that gets the project root file might look something like this. And again, this is a simple eLisp function. I've used defun to define a function that I've called getProjectRoot that takes 3 arguments: the buffer, the repository type, and the init file. The third argument is just so I can define multiple functions with compatible signatures. I have, again, the more complicated version of this function does use the init file variable. So what does this do? Well, I'm actually going to show you by working outward from the Scratch buffer. So if we go to Scratch, and if we type get buffer, I'm going to do runner.py. I'm going to switch to the messages buffer real quick, just as a way of. Okay. So if we go to get buffer runner.py, and we see that that evaluates to a variable that stands for the buffer. Now there's a function called buffer file name, which tells us the file corresponding to that buffer. In this case, there is a file, and it's non-nil. So now, if we want to do, I do probably as a belt and suspenders thing, I use this expand file name function to turn it into absolute path. In this case, that's not strictly necessary because it has the correct value by default. And then lastly, we have VC find root, which is another. That's actually a built-in Emacs function that, given a version control signifier, will tell you what the base directory is for that particular repository. So here we've used .git because this is a Git repository, and sure enough, we have the documents work vbench, which is what we were looking for. So. So this is basically what this function does. And then we define a variable that uses that function as a symbol to indicate what should be done to identify the project root for a buffer. And then after that config variable is set, we have this function current buffer project root that calls the function in question. It uses the current buffer function to find the current buffer, unsurprisingly enough, and then the config variables so that it looks for the correct repository type and the Python module Sentinel. And I have a fancier version online if you want to take a look on that. But this will do the trick, at least to get us started. And now it's left to set the server arguments. So I have a little macro that just adds 2 elements to the end of a list. Won't go to, if you guys are really curious, we can go to more detail later, but just a simple little helper function to make the rest a little bit more readable. And then I use my current buffer project root file to define a variable called project root in the context of this Jedi config setup server args function. And the next command is called make local variable. And that's an interesting command that allows you to make a variable that is local only to the buffer in which that function is called. And that is helpful where you have a situation where you have multiple projects that might be using Jedi, and you want to be able to set the Jedi server args variable to different values depending on what buffer you're in. So the make local variable call is actually quite important and adds considerably to the flexibility that you have in terms of creating multiple environments and using them from the same Emacs session. And then we set our variables. So, and then both of these are just conditional on a project root being defined and the config variable for a virtual env being defined. And hopefully that's self-explanatory enough. It adds the appropriate arguments to the Jedi server args variable, and the idea being that the argument and then the value follow each other. So from there, the sidebar that I mentioned before is one other command that you might find that you need to use, which is to find the correct Python when you can't use virtual env. And I won't spend too much time on this because this is a bit of a corner case, but I have this switched on and off by this use system Python config variable, and it does a couple of things. First of all, it's this set Python executable function. For Mac OS X, you actually need to use this function that's defined in the init.py file that basically takes the path environment variable for the shell and makes it available to Emacs. Again, it's a corner case. More details are online. And if you Google that, you'll get a helpful Stack Overflow answer that will tell you much of what you need to know. And then you make your own local variable again. This time it's called Jedi server command. And then in this case, you set the first value of Jedi server command. You could probably do this with setcar too, to a value given by executable find Python. And just to illustrate what that looks like, if I do that, I get, let's just go. As you can see, the bottom line here is my particular Python, which, as I mentioned before, happens to be that which is installed by Anaconda. So again, for those of you who are having issues starting up the Jedi server, you may need to use something like this in your environment. And now we add the hook functions we defined before. We set up the server args first, and then we set the executable when it's the use system Python variable is set true or non-nil. And then I have a couple suggested keybinds. The functions I showed you before when navigating are basically these 4. To jump, you use the Jedi go to definition, which is great for quickly navigating. The Jedi go to definition pop marker command takes you back to where you were before. That's how we got very quickly back to where we started when we did our little navigation through the project. And then the show docstring command is about what you think. Shows a docstring in a special buffer. And then this Jedi get in function call thing, that's what pops up the function signature when you're between parentheses for a function call. And I find that handy sometimes. And it's actually not bound by default. This is my setup keys. Again, local set key, just to mention that sets a key for a particular buffer if you don't want to clobber global settings for other modes. There's a little hack because by default, Jedi always pops up the getIn function call after a certain delay. I have set that delay variable, which is in milliseconds, to an absurdly large value. And I would recommend that if you use the key binding I've suggested, you do something like this yourself. And in fact, that's done in the VM. And then one other little tweak that I kind of like is the complete on dot, which is that, for example, when you, let's see if we want to go to, so we're going to just go real quick here to, if I did, for example, logging dot, yeah, I get the completions, which look a little odd because of the width of my screen, but I get the completions showing up automatically right on the dot. And that can be useful sometimes if you want to see a completion right upon making a method call. Okay, so that's basically it for Jedi setup. Like I said, this general paradigm does apply to other languages, and the basic idea, the common problem that has to be solved for all of them is telling whatever process is learning about your code where everything is. So some of the things, such as finding the project root and other things, can be helpful for that. And they also will generally follow a pattern where they'll provide some way of connecting to a back end, or they'll provide a back end connecting to the autocomplete or a similar interface. And I think that that's true for all of these. One thing I'll also mention on top of autocomplete is there's something called company mode. I don't believe Jedi has a connection for that as well, but that's something that a lot of people use as an alternative. So, and that basically concludes the talk. So thank you guys all for your attention. I don't know if we have time for any questions, or if there are any questions from the audience, or... Sure.
I'm guessing the answer is no, but does this work with command mode at all? Remote ending?
I haven't tried it. What I don't know is, I don't know if I think the problem is that when you start the Jedi server, you have to, yeah. I think you'd have to give something that's like address like that's a path in the sense that like your system would understand, because it's a separate Python process that has to access those libraries. So I think the same goes also for like if you're like in a virtual machine or something like that. So I think the answer is no. I think you're correct.
Does the Jedi server start up relative to the current directory?
By default, it will have the same syspath as starting Python in the current directory would. So I believe, actually, I'm not.
I'm just asking because for things like if you launch a shell while you're looking at a buffer, and it's in remote, because it's trying to, you'll open the remote shell. So the parts of Emacs understand current directory for like launching programs.
Yeah.
So I was wondering if it would launch Jedi remote, like on the remote machine.
I haven't tried that. I suspect no, because of how much else is going on, but certainly worth a try. In back, blue shirt. Oh.
What's the major difference between versions 2, 3, and 4 users? Just major.
23 and 24? I, haven't noticed, except that when I've installed packages recently, I need fewer hacks to make them work with Emacs 24. Basically, yeah. So there's some other stuff too, but none are coming to mind off the top of my head. I've been using 24, I'm quite happy.
Is the image item for stuff? Are images in comments?
And there was another question from back.
So this sounds very interesting. So if I have like multiple Git repos, each using a different virtual end, can Jedi determine which virtual end to use? Or do I need to give it a hint sometime?
So I've thought a little bit about that. I mean, the solution I have in the VM, I ended up not having time to come up with an intelligent way of doing that, just because that's not part of my own workflow. You'd have to figure out basically some way of given a buffer's location and its parent repository, what virtual end does that map to? And there could be a couple things. You could have a convention about having a particular file, or if there's a file in the virtual, that tells you what virtual env it is, you can have a way to find it and therefore set that variable. So you'd have to do something like that. It's certainly possible, but probably would be more a question of how you organize your project at this point. Yes?
Quick question about projectile one. So it looks like you had no particular set of things to turn it on. So does it start learning, like, if I cd to a directory, then some directory above it has a .git and says that's a project?
Yeah, I believe it does a slightly more robust version of the VC find route. I think it keeps a list of, like, SVN, CVS, Git, and so forth, and then will infer that it's a repository by navigating to that buffer.
Like, oh, that directory is a project, and this other one's a project, so then I can start switching between them?
That's correct, yes. And then you had a question.
I'm wondering, did you show us the vertical layout? Remember you said that was an extra configured.
Sure. If you guys want, I can show you that real quick on my own .emacs. Just give me 1 second. And so this is actually, I took this from Emacs Wiki, which is a great resource. And it's basically this part here where
There's a IDE vertical package.
If there is, then I would recommend looking into that because
Yeah, good. Open up package list and then go through and say, you'll see a bunch of IDE, and a bunch of autocomplete AC something, which are autocomplete add-ins to adding things like autocomplete MySpell. So yeah, it's that.
it's IDEO.
I believe it's IDEO dash. Yeah.
There we go.
Ubiquitous is a good one too.
I don't use ubiquitous.
Sort and time.
So
Oh, that's right. I remember looking at it.
So simple package, simple documentation. Okay, so I take back what I said before, and I recommend that you use this thing that I've never used. That sounds much better. Anybody else? Okay, thank you all so much for your time. Really appreciate it.